Hello, everyone. My name is Kenny. Own a house or interested in refinancing or buying, better.com is sort of a place to go on the internet and get a mortgage, do it a more digital process. So I'm going to talk about, I work on the data team there, and I'm going to talk about predicting customer conversions using DBT and some machine learning light. So before we predict conversion, we have to first make sure we're measuring it properly. And you know, it seems like a basic thing, right? You count the number of people who converted divided by the number of customers you have, like boom, you're done, right? But then, so that's like what this curve is, right? So that's like conversion rate on the left, and then the y-axis maybe cohorted, like maybe it's like the number. It's a conversion for customers that joined that week or something. So that's today. This looks kind of bad, right? Because the number is going down, especially like recently. It's kind of scary. So does this chart look, everyone has this chart at their other company, right? Cool. So yeah, so like, does anybody know what's going on? Can someone, probably somebody knows this. What's going on with the most recent data and why is it dropping? Anybody?
Lag time.
Lag time, thank you, right? So, huh?
It's July, everybody's at the beach.
Oh yeah. So if this is maybe a week out, right, and it takes your customers maybe say if your customers take 2 weeks or a month to actually decide if they want to convert, obviously if 100 people joined here, 0 of them will have actually bought or converted at that time, so it's going to be really low. So there's always this lag time, and you might hear all these hacky things oh, don't look at the last point of this line chart or something like that. So imagine the world of mortgages, right? The lead time from a mortgage application to funding is weeks or months. So this is a huge problem. You can't just do it this simple way. So the solution here is survival analysis, Kaplan-Meier, and cohorting conversion still, but applying this basically very popular survival analysis methodology to account for censored data, which is the official term for accounting for conversions for customers that haven't had time to convert yet. So it solves a lot of problems here, kind of ticking off the boxes here. You can actually look at recent data and have an apples to apples comparison of conversion for this month or versus last month, even if you have a significant lag time. So that's huge for us, and it allows you to do that without throwing away data, right? So you don't have to just do it conversion at day 20, because that's not great either, because you have to wait 20 days to actually see the conversion. So it's really great. This solved, so I'm happy to say actually at Better we use Kaplan-Meier, and these curves are in our company KPIs, and they're the most popular dashboards at the company. So cool to see this being implemented and kind of solving the question of has the data baked enough yet and stuff like that. People are it's become ingrained. It was a big battle. It's probably my first 6 months a year just trying to fight for this, but so that's really great. So that just kind of knocks out the question when it comes to understanding conversion, right? Are we measuring it correctly? So we kind of tick that box off. That's good. So the next step, now that you have this, we want to be able to understand conversion. And by understand, I mean now that we've kind of nailed the methodology, how do we actually understand what's driving variation? And so I used to work for I would embed a lot with our customer support team and our sales team, which is our loan officers. And this is kind of how the meeting goes every month. This also probably resonates with a lot of people, right? So it's we look at the curve, it's yes, we're killing it, high fives, it went up 5 percentage points, must have been all that work we were doing. And then it goes down the next week, and then they're nah, it wasn't us, rates went up last week, or they did this, you guys got to do this analysis really quickly so we can figure out what's going on, right? So it's just you're chasing this stuff, and it's a roller coaster. So this is the problem we're trying to solve, right? We want to apply some kind of systematic way to, just slightly more systematic way to identify and at least begin the process and automate some of the analysis of, and what are the best hypotheses of why this curve is changing a lot. And so at Better, this is a tough problem because, so we're trying to understand conversion of at a high level, submitting an application for a mortgage and funding that mortgage. So it's long lead time, and a lot of things can impact this number. Here are 3 of the big buckets, right? So at a high level, there's customer support. We have a fleet of hundreds of people, because mortgages are complicated, and so you want to talk to a human, and so there's a lot of inbound traffic. We do a lot of proactive outreach as well, talking to customers, walking them through rates, and just providing a good customer support. So obviously our responsiveness and our ability to call people on time impacts whether or not someone's going to go with us, because also obviously the mortgage market's very competitive. There's a lot of lenders out there trying to sell you a mortgage. Quality. So what I mean by this is the eligibility mix of potential borrowers. So what I mean by this is maybe, last month we did this big marketing campaign on Instagram or Facebook that was like targeted towards millennials or something like that, and like buy a mortgage. And surprise, surprise, none of them can actually afford one right now. So it's like they all drop out. And then so obviously that has a big, so that's like a kind of real example of things that happen, but maybe the purpose was not maybe conversion, it was just brand awareness or something. But so those big marketing spends that are not like the sales team's responsibility, for example, can really impact our conversion rates at a company level. And then last is market. So this is even crazier to measure, right? So things like, does anybody like follow Mortgage News Daily? MortgageNewsDaily.com, great place. Check it out. 30-year fixed par is like really going down because of like, so coronavirus is like a great example. It's like market uncertainty, rates are really low. It's basically free money right now. Like if you're trying to mortgage, I'm not trying to sell you, but like. But so there's general market rates. So obviously that really impacts conversion too. If just rates are low, people are going to get mortgages, and competitor rates too. So it might be like Quicken Loans or these other places. They might be underselling us. So it's really that spread. That spread is also really drives more conversion a lot for us. So we need to like kind of model each. We need to build features within each of these categories and kind of weight them against each other. So the requirements, right? So there's obviously like a causal piece here. We want to be able to say like conversion went by X because of Y. And interpretability is really important here too. We want to be able to say ultimately like looking at a graph saying like this example, decreases in customer support responsiveness were responsible for a 15 basis point decrease in conversion this month. That's like the ideal insight that I want to drive with this tool as a requirement. So in that statement, right, there's like a causality measure there and there's interpretability. And so before I do dashboarding, I think it's always, somebody gave me this tip once a while ago to always like sketch out what your dashboard's going to look like before you draw it. I think it like really just helps you think a little bit. And so this is like the very first thing I drew. Y-axis here is like conversion last month. So it starts like 22%. It's like this like waterfall viz that I'm trying to do where it's like, oh, like we called people more. So it went up two basis points, and then we had better leads, and then maybe pricing went up, so it went down, and maybe you can hover over it and see the daily trend. And then you can see this like final summary of like expected to current. So now I can show you what it actually looks like. What should I? QuickTime? Or? As we pull that up, yeah, so I can talk about, I can talk about the tech stack. That's cool. So the tech stack, which I'll go into a little bit, we ended up building it with DBT. There's kind of three aspects of this project, right? There's the feature engineering, the modeling, and the visualization aspects. So feature engineering, we use DBT. It's just cleaning, that's like compiling all the market rates data with the sales data, with borrower profile information. That's like all the joining and cleaning. The modeling, we use Convoys, which is a open source like survival analysis library that we built at Better. Eric Bernardson, Mr. Luigi, as I call him, this guy who wrote Luigi. He wrote that, it's like his new thing. And we built a lot of internal ecosystem around Convoys to do a lot of basically survival analysis modeling. And then, all right, here's the demo. So good. Thank you. So this is the final product. This is Tableau dashboard. So you can see kind of at the top, you can compare like this month, conversion is trending relatively worse by this percentage, and it breaks out those categories I mentioned, like sales, quality, market rates. So you can kind of read this as an executive summary, like it went down 2.5 percentage points. Maybe we can say like, oh, it went down one of those three is because of sales. And you click there and you can see all the features within the sales bucket, and you can see like, okay, this is how like our calling rates, and then you click that and you kind of see like the distribution of how we're calling people over time. And so you can see actually did go down that month by like a little bit, probably just, it was holidays, so people were like on vacation and stuff like that. So that's kind of final tool. So you can kind of log in and just like really quickly weight, which is the important thing, all of the features like explanatory power against each other, which is nice. So that's finished. That's out there. So tech stack, I'm going to go over this briefly, not a huge amount in detail, but DBT. So we use this for feature engineering. This is what the code used to look like. like all of our ETL pipelines are just pd.read SQL of these crazy SQL strings, right? It's like why are we doing this? And so moved all of this to dbt. And you get a lot of stuff for free. You get like a feature catalog because of it, which is really nice. And you get a material, and I also would materialize this intermediate table. So other people could use this analysis outside of just this project. Convoys, I mentioned this. This is the internally developed open source software survival analysis library use. So we're fitting like Weibel regression is like the model we're using. So it bakes in, it accounts for censoring, so we don't have to add that as like a feature. The model picks it up. We can use this to predict new data points, which is really nice. And we use it a lot. If you like lifelines, it's a similar flavor. We have also built a lot of internal functionality around it that we hope to open source, just make it even easier. And then finally, Tableau for visualizations. So that's kind of, I'm a big Tableau person. I think it's really great for this interactivity kind of piece. It's just not the most reproducible, unfortunately, so it's like kind of a pain to go in and like change things. But overall, for like these like really deep, pretty looking graphs, I think of it as like the Photoshop for like data viz, really. So yeah, this is kind of how it all stitches together. We're Redshift house, dbt feature engineering. It gives you this flat data set. We send it to Convoys. Convoy saves the weight somewhere into our DB, and then we have like one final clean job to like put it in the shape that tab needs to actually from this project. So one, the most important thing is focusing on an end-to-end solution first. So right away from the beginning of this project, it's like we're going to understand conversion. The first thing you have that meeting with a stakeholder and just like, oh, we should measure, this kind of like treasury rate, or like, are we measuring like page views on this website? Can we like include like email responsiveness plus text responsiveness? So it's like a long list of hundreds of features. And just, it's very tempting to fall into that modeling rabbit hole where you're just feature engineering all like 100% of your day. And that's all. And then even worse, if someone is like, someone's like, oh, should we use like Weibel curve or like generalized gamma, or like should we just use logistic regression? It's like, I'm like, like at this point where it's like training a model is like one line of your code. I'm starting to think like, whenever someone asks me that, it's kind of like feels like someone like a peer review is like, have you considered using like if then instead of case one in like a SQL statement? It's kind of like at that level, it's just like so unproductive, and not the hardest part at all of this project, right? Like, so the first thing I did was like I built the simplest, dumbest model that I could. It didn't even work, but focused on like the pieces. So making sure that it's in production immediately. The data's flowing in like every day. So like those are the things that are hard, and stitching it together, making the Tableau viz works. So I think that's the first thing to avoid. Just like kind of tune out the noise of like the feature stuff, and then get it to work end to end, and then like iterate on the model later when you actually buy yourself some runway. And the best part about that is you can show your stakeholders that like in a week you can stand something up, get feedback, and then iterate from there. So it's a lot faster feedback loop. Materializing a clean data set. So this was also big, and like a really great, like also like on the DBC side helped a lot. So I viewed this step as, so I talked about like the sort of clean data set I used for modeling, and materializing that in Redshift directly before, and so it's kind of like decoupling my feature engineering from modeling. I think a lot of times I'll see models that just like have, again, like maybe either like pandas transforms, like dropping NAs or like SQL stuff in there. So kind of like splitting that out was like a big workflow improvement, I thought, but also I thought of it as like a hedge. So like, even if your modeling project, even if this doesn't work and like it's not useful and nobody uses this product, I'll at least have this clean data set that like people can use. And like, I'm pretty confident that that's gonna add value to the company. So I think it's like always everybody likes clean, like, it's just like clean data is like something that nobody really wants to do. So it's like a nice way to add value, even if everything is kind of like hits the fan. And like again, like building a feature catalog and all that kind of good stuff. So definitely materialize your intermediate data sets if you think other people will find them useful. And then last I would say is selling hard to the business. So like I did this, I shipped the Tableau, it made a few decks when it first launched, and like I went to the meetings, but it's never done, right? Like people just assume, oh, it's up, like that's great, like you can move on to the next thing, and that's kind of what I did. But But the problem is like people forget, right? And like people are really used to their existing processes of how they do work. And so, and what's worse is like people don't like, sometimes your customers need you to draw the line of how this is actually going to help, and you have to just repeat yourself over and over again. The cheeky title for this talk was, I gave the business exactly what they wanted and they didn't use it. So, and I think that's kind of like, but you can use that for a lot of things. But that is kind of like, so I think you can't just trust that like you give them exactly what you want and it's going to be magical. You actually really do have to hold their hands, like invest 10x the time after you're done to actually sell it. And people like, yeah, that's just, otherwise people are just going to forget and it kind of falls by the wayside. So I think that's really important to always think about connecting it with the business value at the end. Right, so that's Wizard. Just a few plugs as well. I would say if you're interested about this project in particular, the tech, like I go into a little bit more detail what the tech looks like on the Better Engineering blog. Wrote a post about it. Data Science Roundup featured me, so I can cross that off my off the old bucket list, you know. Data Better, you know, everyone's hiring, right? So my team is 15 data engineers right now. We tend, if you're interested in particular, like I would say, our profile tends to be like data scientists who are more interested on the engineering side than average. So if that sounds like you and you owning things end to end, you're tired of notebooks, you know, you can but maybe Data Better is a good place. And then this is my personal, you feel free to email me or hit me up. So thank you. Do we want to do questions?
Yeah, we'll just do a couple and then we'll break for drinks. Any questions? I'm going to go here first.
Hey, can you talk a little bit more about what the nature of the clean data was, like the materialized piece?
Yeah. So the kind of like the grain was like, so every like, the key entity for us is like a loan file, which is essentially a mortgage application. You can kind of see the schema here. This is a bad example. It's on the account ID, I guess, but it's kind of the same thing. It's like a customer. And then basically but if it's account or something, and every column is like, you know, had a successful call with us. That's like a sales example. It's like, it's all the features there. All like, all generally like dumbified as well, I believe. I think it's also kind of see it.
Account ID is in one column per feature basically.
Yeah, here you can see a little bit right there as well. So like, you know, this loan file ID, is it from bank rate? One or like, or I guess actually in this one it wasn't actually. Yeah, sorry. Our internal library, like you can send, our internal library does all the dumbification for us. So you just send a, it can be like a mix of types and stuff like that, categorical, numerical, and then the library will take care of a lot of the shaping and prepping it for modeling. So it's pretty usable. Like, so it says lead source, things like, you know, what was the like interest rate on this mortgage, all that kind of stuff. Like it ended up being like a dozen or so features across like all those different categories. Yeah.
Great talk, thanks. I really like the kind of like full stack approach to this type of stuff. And I think one thing it highlights is, you know, is DBT used to create data sets that feed into products, or is DBT used to create a data model, right? And then those like kind of like end product like models are used in like a bunch of different like downstream use cases. I'm wondering, like, does better, you know, maybe the trade-off is if you're creating a data set, there's like a bunch of redundancy between data sets, multiple sources of truth, et cetera, but you get autonomy to like fully own this thing full stack. I'm wondering, does like better prefer the full stack method? You guys use DBT in like both use cases? Any kind of opinions you guys have on, you know, are you building a data model, or are you guys kind of like fully autonomous end-to-end build data sets with DBT?
Yeah, so I'd say it evolved. So I've been there about a year and a half, and a big change is even like just like maybe 2-3 months ago, it was 3 when I joined. It was probably 5 2 months ago, and it's like 15 now. So it's like really crazy. Like, I don't know why, just like we chunked it that way. So back in the day, it was like wrapping, it was mostly just embedded. Like the modeling was never materialized in most cases. And it was very autonomous for that reason. At this point now, I've actually, like, interestingly enough, that like the materialized data set that I made for this has kind of transformed into like a core loan file, like data set that's going to be used like across the company. So I think what's happening now, it's still kind of a mix. Like we definitely have. I'm moving more towards like I'm more focused on like data platform stuff now, and I'm focusing on that like centralized, just like writing good standardized central data sets and managing the DBT ecosystem. But that's only like maybe only me and like a few other people are worrying about that. Everybody else on the team still is using DBT, but it's still like it's fairly autonomously managed at this point. So it's like I think it's a good mix where yeah, like people are using it pretty independently and like have free reign, but we're just starting to introduce some level of process and centralization so that we can avoid the source of truth problem.